Good evening. Good evening. Good evening. You are welcome to our tutorials for today. Today we'll take a look at chemistry. Okay. Today we see how far we can go with respect to the rest of the gas laws. The rest of the gas laws. Okay, so as usual, we'll pick questions from the first questions and see what we can make out of it. Says, what is the temperature of a given mass of a gas initially at 0 degrees Celsius and 9 atmosphere. If the pressure is reduced to 3 atmosphere at constant volume. Option A, 91 Kelvin. Option B, 182 Kelvin. Option C, 373 Kelvin. Option D, 819 Kelvin. JAMB 1999, question 5. Which gas laws are we supposed to apply here? Which of the gas laws are we supposed to apply here? Huh? Avogadro's law. You got okay, I state it. Huh? So if you cannot state it, then how did you know that is Avogadro's law? See, first thing to do is to find out which of the parameters is constant, is or are constant, and which ones vary from this question. Which one is constant and which one? In fact, how many parameters are there first? Name them. Temperature, pressure, volume. I agree. So which of them is constant? So which of them vary? Good. So which law? Which of the laws that will have the volume constant, then temperature and pressure vary? Pressure law. Pressure law. So in pressure law, the pressure varies directly proportional to the what? Temperature at constant volume. So in pressure law, pressure is very proportional to what? Temperature. While volume is what? Constant. Is it clear? Is it clear? So that means volume is under case. So that means pressure is equal to what? KT. Pressure, volume is inside constant. Hope you know. Remember, there are other factors that are kept constant. Volume is one of them. Am I complete? So that's why I said that volume is inside what? Constant. It's a constant. But P is equal to what? KT. Are we together? So either is K, that means K is equal to what? P over what? T. Right? Remember that K1 is equal to what? K2. Therefore, P1 over T1 is equal to what? P2 over what? T2. This is pressure law. Is it clear? So, with this now, let's solve this question. From the question, P1 is what? Is what? 9 atmosphere. T1 is what? Huh? So 0 plus what? Is equal to what? 273 watts Kelvin. Then T1 is equal to what? Sorry, I mean P2. P2 is equal to what? 3 atmosphere. This marker is not writing well. 3 atmosphere. So then T2 is equal to what? We are looking for T2, right? Right? So if we now, can I clean here? Here. Or the question, can I clean? Question, okay. So if we make T the solid formula here, it then implies that T2 You cross multiply. T2 is equal to what? P2 T1 over what? P2 T1 over what? P1. Are you following me? So it's not equal to what? P2 is what? 3 atmosphere. Times T1 is what? 373 Kelvin over P1 is what? 9. I believe 9 atmosphere. So atmosphere will cancel atmosphere. 3 into itself 1. 3 into 3, 9 is what? 3. Sorry, this is 270, not 37. 273. So 3 can divide here, right? 3 divided 27 is what? 3 divided 3. So the answer is what? 91 Kelvin. Is that correct? Option what? A. Any question? Any question? Look at another question. Hope this one is clear. Good. How many gas levels have we treated now? 5. Name them. Name them now. Boys law, boys law, and what? Good. Okay, let's pick another question. A gas occupies 30.0 dm cube at standard temperature pressure. What volume would it occupy at 91 degrees Celsius and 380 millimeter mercury? Option A, 20.0 dm cube. B, 40.0 dm cube. C, 60.0 dm cube. D, 80.0 dm cube. JAM 1979 question 45. Are you done copying questions? Put out questions. Can you solve this question? From the question now, what gas law do you think we should apply? Huh? Huh? Is that what? Is that what? Huh? You don't know. None of them is constant. She. A gas occupies 30.0 DMQ as standard temperature pressure. So we have our standard temperature pressure. So standard temperature is what? We will discuss this. Don't tell me what we're talking about. We discuss this. Where's your phone? When we discuss temperature 273 Kelvin income, pressure 360, 760 millimeter mercury. Have you forgotten? Huh? Is that what? Huh? Pressure is 760 now. When you're asking me, is it descending with 1 atmosphere? What is the value in atmosphere? I told you 1. Can you remember? And a meter per meter square is 1.0 some 1 or so times 3 is for what? 5. I've forgotten. Hey, please don't forget like that. To solve this question, we are going to use Gerard equation. This equation combine, you can combine Charles law and Boyle's law and get the general gas equation. You can combine Charles law and pressure law to get it. You can also combine Boyle's law and pressure law. You can combine Charles law and Boyle's law and get it. You can combine Charles law and pressure law. You can also combine Boyle's law and pressure law. Either of them, you get general gas equation. Am I communicating? Now, if you combine Charles law and Boyle's law, remember what we did that in Charles law, the constant is equal to what? Constant is equal to what? In Charles law, what are you saying? Check your notes now. Check your notes. Are you sure you read? Yeah. Hey. You don't be as if you read. K is what in Charles law? Pressure one. No, now. Can you go through your notes when we did that volume is equal to less proportional to temperature? So what did we get there? So you can remember this thing. Look up, please. So you can remember that volume is directly proportional to temperature. Say it now. You are saying it's here. I ask you a question. You say you don't know. You say you are not. You don't read. You are telling me it's here. Say it. Let me hear it. Say it. What is it? K is what? You are discouraging me, but don't know. You are discouraging. How can I teach you something? You go, you do not read it. Then what do you do at home? Check it now. Does it make sense? What do you do at home? You have an exam almost 2 weeks or 3 weeks. You have to do something, you did it, you not read it. I am not happy with this thing you are doing. I know that Charles law, volume is also proportional to what temperature. Is that not what we say? A constant what? Pressure. Constant is not pressure. Because there are other things that will be inside a constant. I understand that V is equal to what? KT. Then K is equal to what? V over what? T. This is what I'm asking for. This is what I'm asking for. This is the value of K in Charles law. I know that the pressure is constant. It's inside this K, I know. But everything that is constant is equal to what? V over what? T. You can't just equate pressure to constant like that. Am I completely good? Now, that's why I say that. I asked that question. In Charles law, in pressure law, Charles law, K is equal to what? V over what? T. Then in Boyle's law, K is equal to what? No, what are you saying? What are you saying? State Boyle's law for me. State Boyle's law. This thing you are doing is wasting our time. And I don't like it. This we are doing is wasting our time. I don't like it. It makes me talk too much, and time is going. State Boyle's law, that's the question. So if it's inversely so pressure, right, is worse. So what should be here? Volume. Is that what I thought about the Boyle's law? You know this word I have been teaching. I'm not asking you, so let me even know whether you are graduate I will say. If you prefer that way, I don't teach and doing my way. Then it's your business if you pass. Your business. But I need to find out if you actually have been going through what I'm teaching you. That's why I'm asking you this question. And it's clear that you don't read it. Am I right? It's clear you don't read it. What do you now do? Then, if you cannot make what you did here, what can you do? If you cannot do what you did in class, then what else are you doing? That you come here and sit down for 2 hours, or 1 hour or 2 hours, I'll teach you, don't know it, you go home. Then you go and start reading something else. Then what are you doing? Then why are you coming for tutorials? What are you coming for tutorials? You're making me waste our time here, and I don't like it. Is this what I taught you in Boyle's law? So what should be here? Good to be soft like this. Is it not very vast? This one is direct now, which is wrong. It's not Boyle's law. You know what? Let me just keep solve. If you want to read, if you don't want to read, that is your problem. Let me just solve this thing. Alright, so just know the general equation state that I told you that you can combine Charles law and Boyle's law. You can combine Charles law and pressure law. You can also combine pressure law and Boyle's law. So if for pressure law, for Charles law, volume is equal to what? Temperature. While for Boyle's law, pressure, this one is a constant what? Pressure. Volume is much important to what? Pressure. A constant what? Temperature. This gas equation is a kind of give rise to what's called joint. It's a joint variation. You know, Boyle's law is inverse variation. Do you know about variation? Boyle's law is inverse variation. Charles law is a direct what? Variation. But general gas equation is a joint variation where we combine two of such variation. So here now, if you combine this variation and this variation, you get what? General gas equation. Look up, volume is here, right? So we now, if you combine these two, you have something like this. Volume is directly proportional to temperature and inversely proportional to what? Pressure. How do you that? If you combine two of them, this one will be on top. This will be below. What this means is that volume is directly proportional to what? Temperature. Charles law. The same volume is inversely proportional to what? Pressure. Boyle's law. You have combined the two of them. This is general gas expression. Watch out now. If you want to make this to now to be equal sign, this will disappear. You put K. So V is now equal to what? KT over what? P. Are you following? Now let's make K the subject of the formula. K is now equal to, you multiply, right? P V over what? T. Is it clear? Now, if you move from K1 to K2, they are equal. So that means this whole thing will now become P1 V1 over what? T1 is equal to what? I follow you. P2 V2 over what? T2. Is it clear? This is general gas what? Equation. You can use this now. This is Charles law. This is what? Boyle's what? Law. So if you combine Charles law and Boyle's law, you can get the general gas equation. Are you following? You can put this down. I will show you what happens when you combine Charles law and pressure law. Put this one down first. What we need to solve this question is just this thing. Remember, I'm just trying to teach you. I'm just trying to prove that where this thing was derived from. But to solve this question, just look at the formula we use to solve the question. Let's see how we can get this general gas equation using Charles law and pressure law. Charles law and what? Pressure law. Let's see how it will look like. Now, this is Charles law. The way that pressure law state that pressure is very proportional to what? Temperature. Are we together? Good. That means if you look at the two of them, this one, the volume pressure is constant here. Volume is what? Constant here. Now, volume is directly proportional to what? To what? Temperature. While pressure here is directly proportional to what? Temperature. So what you do? We have two temperatures here. Hope you know. So because we have two temperatures here, we pick one. We have a case like something like this. This now we give rise to PV. PV is directly proportional to what? Temperature. Is it clear now? Is it clear? PV is directly proportional to what? Temperature. Are we together? Now remember, to remove this, you put what? K. So PV is now equal to what? KT. Are we together? So let's make this K the subject of the formula. K is now equal to what? PV over what? T. Remember that if you move from K1 to K2, they are the same thing. So that means P1 V1 over T1 was also equal to what? P2 V2 over what? T2. So that means P1 V1 over what? T1 will be what? P2 V2 over what? T2. Is it clear? So this is the Jeragas equation. So this one came from Charles law and what? Pressure and what? Pressure law. Put it down. After this, I also show you how you can get it from Boyle's law and what? Pressure law. Fast. See how we can derive this from Charles law and what? Sorry, from Boyle's law and what? Pressure law. This one is pressure law. So let's write Boyle's law here. Boyle's law says that what? But what the Boyle's law says that P is what? Inversely proportional to what? Volume. This is Boyle's law. So this one is what? Boyle's law. This is pressure law. So if P is inversely proportional to volume, and the same P is directly proportional to what? Temperature. If you combine the two of them, you have something like this. That P, we already know what one of the P's, right? Is directly proportional to what? This is going to be here, temperature or volume. Is it clear? Is it clear? So from this now, if we cross multiply, or let us not cross multiply first. Let's remove this sign by putting constant, right? So P is equal to what? KT over what? V. P is what? KT over what? V. So if P is KT over V, let's make this K the subject of the, are you sleeping? Stand up. Let's make this K the subject of the formula. We cross multiply. So KT is equal to what? PV. True of us. So we make this K the subject of the formula. So K is now equal to what? PV over what? T. All together. Now remember that K1 will always be equal to what? K2. So that means if K1 is equal to K2, that means P1 V1 over T1 will be equal to what? P2 V2 over what? T2. So this implies that P1 V1 over T1 is equal to what? P2 V2 over what? T2. This is the same word Jeragas equation. Are we together? So have you now seen how you can derive this equation using combining Charles law and Boyle's law, or Charles law and pressure law, or Boyle's law and what? Pressure law. The end of these three combinations will give you this Jeragas equation. Derive this. Let us now use this equation to solve this question, and this will be our last for the day. Hope you grasp what I explained about this. So I hope you can derive it yourself. Are you sure? So let's use this formula to solve the question. So solution. From this thing now, P1 is what? From the question, P1 is what? The standard, right? Which is what? 760 millimeter mercury. This one is absolute temperature. Hope you know. So T1 is what? 2 what? Kelvin. Then V1 is what? 30.0 dm cube. P2 is what? P2 is what? P2 is what? For communication. Good. 380 millimeter mercury. Then T2 is equal to what? 91 plus what? 273 Kelvin. The answer is what? This is 4. 7 plus 9 is 16. You put 6. Carry one, put here. 3 what? I following. 364 Kelvin. This 1 plus 3 is 4. 9 plus 7 is 60. You put 6. Carry one, put here. 3. 364 Kelvin. Out together. 364 Kelvin. Kelvin. So let's now solve this question. We are looking for what? You know one, right? Is it complete? V2, right? V2 is what? Unknown. So let's make V2 the subject of the formula here. From here now, V2 is equal to what? We cross multiply, right? This times this. P1 V1 T2 all over what is remaining here times this, right? You get what? P2 what? T1. Is it clear? So let's substitute the values given here. Sorry. P1 here is what? 760 millimeter mercury times V1 is what? 30.0 dm cube times T2 is what? 364 Kelvin. All over P2 is what? 380 millimeter mercury times T1 is what? 273 Kelvin. Are you there? So Kelvin will do what? Cancel Kelvin. Millimeter mercury will do what? Cancel millimeter mercury. We're left with what? dm cube, right? dm cube. So let us now divide. This is half of this. Hope you know. 380 is half of 760. So if 380 divides 760, the answer is what? 2. Good. We're left with this one here. We're left with what? This one here. 3 can go. Hope you know. Are you aware that 3 can go here? If 3 divides that, we have what? 10. If 3 divides 273, we have what? Good, 91. I like that. I like that. Good. 91. Get out of here. 91. So, can 91 divide 364? Look at it well. It will give you 4. If you multiply this by 4, it will give you 364. 3 times, then 4 times 1 is what? 4, right? 4 times 9 is what? 30 what? 4 times 9 is what? 36. It's not. 4 times 9 is what? So that is this times 4 really what? 36. So if this divides 34, the answer is what? 4. So we are done with the division. Let's multiply out. 2 times 10 is what? 20. 20 times 4 is what? 2 times 10 is what? Times 4. 80, 80 watts. 80 watts. dm. So the answer is what? 80 dm cube. Let's look at the option. Is the option there? Option what? D. So the answer is what? D. Is it clear? Any question? All right, I think we will stop here for today. Thank you very much for coming around. But there's room for improvement. Please, I want you to study hard. Please, when you go, before you read anything, go through what you have done for the day. Please, like today now we do chemistry. Go through what we have done for today. If there's anything you don't understand there, you can always ask me questions. Send me quick chat me up on WhatsApp, so I will explain it better to you. Before you be doing other things, you need to read. Don't abandon what you learned here and start doing another thing. Does it make sense? If you leave what we did here and start reading another thing, that means your coming here is a waste of time and money. It's not true. It's not true. You keep quiet. It's true now. All right, thank you very much. See you next time. God bless you.